So we're going to escalate this and add 3 vectors in 2 dimensions. I've given these units that you're going to get comfortable with this week, actually next week. So don't worry about the units just yet. They'll make more sense as we move along. But what I want to say is, what is the resultant vector for adding vector A plus vector B plus vector C? And for a lot of people, this looks intimidating. And then I get a lot of questions about, well, how do I know how to do the trig and everything? And we're going to talk more detail about that as we go along and do more complex problems. But just trust me on this. The first step that you have in any of these is to write out. So write everything out. Write out in components. In components. Almost fit that S there. So we're going to write these vectors out in component form and then add them just like I did with the 1 dimension. So I'll add up all my X's and all my Y's, and if I had Z's, I just add all those up too. And that will give me my resultant vector. So let's make this less daunting by writing it out. So I'll write out my A vector then is what I have. Let's see, just Y. I have 0 in the X. And this is going up. And here is the important thing you'll hear me emphasizing over and over again, is the first thing you want to do before you start defining signs here is define what is positive. For now, let's just go with the standard. Up is positive and to the right is positive. So 0x, and it's going up in the y, so plus 3, and I'm going to leave the units off for now so it's not quite so cluttered, plus 3 in the y. B. Let's leave that one there for now. We'll come back to it. And then C, let's see. I have something in the X now. This is my X axis. So let's see, I have, that says then, if I define that as positive, I have 5 in the X hat. And again, this one's flat. This is all on the X axis. In fact, let me just draw in the axes. Make this, we'll extend this down. Well, it's kind of a straight line. Go like that. So here is my X and here is my Y. So this here is all on the X, so I don't need to worry about it. So this is 5 in the X, let's see, and nothing in the Y. Let me stay color consistent, plus 0 in the Y. So far this is straightforward. It might feel a little awkward because you look at this and you're like, how the heck do those two things equal anything? When in reality, if I just added these two, my resultant vector when I'm done would be something very similar to that vector. Because this gives me a coordinate that says the resultant vector is going to be 5 over in the X and 3 up in the Y. So I would draw a line connecting that point from the origin. And that's the resultant vector. Pretty cool. So now for my B, let's see, what do I got? I have this thing going at an angle, and on the handout, I think it says 30 degrees. I've intentionally changed it here to 33, so I don't accidentally mislead you on what you're getting. Let me use a different color here. What this thing is saying is that I have an X component to this vector coming out like that, and a Y component to that vector going up like that. So I need this Y piece, and I need this X piece, and that's the information that goes here. So I look at this, let's remind ourselves of some trig. Here is the angle. So we have some memory tricks over here. So, you're online. You just write those down so you can remember what they're referring to. So says that sine of an angle equals opposite over hypotenuse. And this says that cosine of an angle equals adjacent over hypotenuse. And then tangent of an angle equals opposite over adjacent. That little mnemonic means. And so what this will help us do is we can say, okay, I want this X piece. So I know that this thing here is 6 newtons. That's the hypotenuse of this right triangle that I've made with the X and Y pieces. That's my hypotenuse. Opposite over hypotenuse, I know the angle. So if, I'm sorry, we're doing the adjacent side. Sorry about that. So I know the hypotenuse. I know the angle, so cosine of 33 degrees. Well, that gives me this adjacent side. That defines for me the length of the x vector. So then this one would become, let's see, I would have a hypotenuse, which is 6 times cosine of 33, cosine of 33 in the x hat, plus, because that vector is going up, so it's positive. Now this is the opposite side. This side is opposite of that 33 degrees. So again, I look here, I have the hypotenuse, moving it over here. We'll point to the right trig function. Moving it over here, I end up with the hypotenuse, this 6 newtons, times the sine of the angle, which is this 33 degrees, will give me the opposite side, that y length. So plus 6 times sine of 33 in the y hat. There you go. Now I can add them together. So look here, grab out my calculator. Whoa, try to break my calculator. So first thing I want to do on my calculator is check, and I am indeed in the wrong units, because this is in terms of degrees. My calculator is currently set to radians. I don't know if you can even see that. So I need to change it, and this is one thing I encourage you to do, and I'd have everybody check in class so you don't do the right thing and get the wrong answer only because you have the wrong unit set on your calculators. So I encourage you to push this in and make sure you get the same values as I do. Let's see, so this gives me 6 times cosine of 33. And then, so that's 5.03 plus 5. So in the x hat, I have, plus that 0, I have 10.03 in the x hat, plus 6 times sine of 33, 3.26. So plus 3, there's a 0 there, so plus 6.27 in the y hat. So again, this value here was 3.27, and this value here was what, 5.03. So that's, I add those to the 5.03 to the 5 in the x hat, and the 3.27 to the 3 in the y hat, and I get this value. So this is my resultant vector. So think about what that information tells us, because this is the thing we're going to use a lot of this quarter. So that tells me I'm going to go over, label my axes, here's y, here's x. It says I'm going to go over 10 in the x, so I don't know, about there, and a little bit more than half as far up in the y. So maybe about like there. So my resultant vector, starting from the origin, points straight to that line. Let's see if I can do a straight line. Probably not. Oh, I did it. That's exciting. Okay. So there is my resultant vector. Because math-wise, we get kind of excited about knowing where it lives, but the magnitude of this is what means the most to us. And you'll see why when we start doing forces in the next couple videos. So what do I have here? I have that this x length is 10.03, and then this y length is 6.27. So I want to do the math. I want the magnitude of this thing. So this is then, let's see, this is A, B, C. Doesn't matter which one you do. It's just Pythagorean. So A squared plus B squared equals C squared. Or this magnitude, C, is the square root of A squared plus B squared. 10.03 squared plus 6.27 squared. It doesn't matter which one you call A or B. It really doesn't. Just stay consistent so you know what you've referred to. So I'm just going to square both and add them. So 10.03 squared plus 6.27 squared to the 1/2 is 11.8 So this magnitude here is 11.83. So what would that be? Well, we're going to do forces and you'll learn what those are. This would be like, that is how much I am pushing with a net force in that direction. Or this could be going down a river where the river has a velocity in the x, so we have some current going, and let's see, we have wind wave pushing us this way. So we end up going this way, and we want to know how fast we're going in the end. Bada bing, that's how fast we're actually going. So that's how you can interpret these results. And then the last little piece I can do, I'm going to run out of space. I'm just going to kind of, no, I won't be that sloppy. We can define what that angle is. So there's a reason I did the TOA. So you can see this. There we go. So the angle of that, let's see, is tangent equals opposite over adjacent. So tan of theta is opposite, let's see, opposite is my y component, so the 6.27. 6.27 divided by that 10.03. 10.03. So the tan theta of that equals that. And what that says is that this angle is just contingent on the proportionality of these lengths. That's all any of these trait identities say, is that if I have this right triangle, all my angles are just giving me a ratio of everything. That's it. So I have that. Now I want to solve for it. In case you haven't seen it, I'll go ahead and show you this step. So if I do this thing called arctan of both sides. In most of your calculators, you'll see this -1 notation. I was double checking on mine to make sure it's there. That -1 notation says I'm taking the arctan of it. Or you can think of it as I'm taking the inverse of it. Or another way of thinking of it is this side, I'm dividing tan by tan. So what this simplifies to is that I get this angle, whatever angle I want is the arctangent of the ratio of those two sides, divided by 10.03. Plug that in my calculator. Arctan of 6.27 divided by 10.03. Okay, so pardon my pause there. I'll put that in the calculator, and I thought, did I magically change that into radians because I got an answer of 0.0109, which this does not look like that kind of triangle to me. It's not going to be a teeny tiny angle. So what I didn't do is do the arc. I did the tan of. So just as a reminder that if you get an answer, don't just write down what your calculator spits out. You can push the wrong buttons and get the wrong answer or not have the right unit set in your calculator. So I put all that in and I get that that angle is 32.01 degrees. There we have it. So now you've done vectors in 2 dimensions and 1 dimension, and we've done some dimensional analysis, and now it's time for physics.